Here we have the program for the neural net, where the majority of the mathematical modifications is from this evaluate definition. And the trick to doing this is to extract out x and y tuples in the test results. So x is going to be standing for the prediction made by the neural net, and y is the target desired results. So for this instance, we want to calculate the mean squared error. First, we took the difference and squared it and declared it as a variable, and then plug that into the formula of the NumPy library and returned it. And for the cross entropy, it was complaining about values maybe that is too close to 0. So we declared an epsilon value, which is very, very tiny. And then we modify the predictions number. And then plug that into the formula for cross entropy. And again, taking into account that it doesn't like numbers that is too small. And we use some external math libraries to calculate the log likelihood. Again, using extracted values. And once we figure out how to do that, it's pretty straightforward. So the function returns 5, like all these different values, and once it is declared in the stochastic gradient descent function, we adjusted the print statement to account for these different outputs. And to show that it works, here we can go to the Python library, and definitely runs, and maybe we can take some testing data. That was already declared, and then we can see it's working totally fine.